It's about time. So first off, welcome everyone for attending our AIOps Power Workshop on Live in ServiceNow. We typically run these with a specialized set of, determined set of our audience from a customer standpoint, but this one we're making it more broadly available to the wider ServiceNow install base. And we will be focusing on health log analytics. And before I begin, just want to highlight some safe harbor notice. We are not going to be covering any roadmaps, but if we do mention anything around roadmaps, we're not guaranteed to actually deliver on them. Just want to get that away. So if you want, to give you a few minutes to read this, but if we do mention anything forward-looking, just keep that in mind as a safe harbor. So before we jump in, I just want to go over a few housekeeping items for today's event. Please use the Q&A button at the bottom of your screen to ask any questions you have during today's event. We'll try to answer them throughout the session or at the end. At the bottom of your screen, you'll also find the reactions button. Give us a quick reaction, let us know you found it. Great, now feel free to use reaction to QA along today's presentation. We also will be sharing today's presentation and the recording after the event. After this webinar, you'll be prompted to fill out a short survey. Your feedback is super valuable to us. So if you have time, please take the survey. Next, I want to first introduce all the presenters as well as lab gurus, and I'll kick it off with Will, who will be leading the lab session. Will?
Thanks, Dennis. Welcome, everyone. My name is Will Hallam. I'm an ITOM solution consultant here at ServiceNow. I've been here for 4 years, and before that, I spent 6 years as a ServiceNow customer using a lot of the ITOM capabilities. And just welcome. Thanks for joining us today.
Hi, everyone. Hi, everyone. This is Tarane Parvarish. I'm the solution consultant for service operations. I've been with ServiceNow for 3 years, and prior to that, I was working at a big insurance company for 10 years as a customer, and happy to be here today.
Hi, folks. Brandon Strickland. I am on the same team as Will. We're partners in crime as well, Richard. I just passed 11 years, half of which in services, and now enjoying my time over on the pre-sales side.
Hi, my name is Richard Brownstein. I'm also in the criminal enterprise with Brandon and Will Hallam, and I'm an ITOM specialist, and I've been with ServiceNow for about 10 years.
Michael? I think he's on mute. All right. Actually, two Michaels. All right. So there's Michael Blazer and Michael Hart. They might be tied up in some meetings that's going on. There are also lab gurus and will be supporting the lab. Doug is from our ITOM product success organization. He's not on now. He'll be joining at the end to talk about some of the services his team delivers. So his team focus on helping customers from an adoption standpoint and getting a quick time to value. My name is Dennis Gaidin. I'm an outbound PM in the ITOM AIOps business unit, and I'll be going over a quick presentation and then I'll handing off to Bill. Well, so again, we do a lot of these live on ServiceNow events. A lot of them happening daily, weekly, monthly across various business units. If you want to register or see what the schedule is, you can just scan that QR code. But this happens, all the time. Next, I'll go over the agenda. So for today's agenda, I'll do an HLA overview. Then I'll hand it off to Will and his team of lab gurus to go over the hands-on lab. Then I'll end it off with a getting started with Doug and then a closing. So before I start, everyone will need to actually request an instance. You can scan the QR code. You can click the registration URL and get your lab instance ready, as well as download the solutions guide. These labs are going to be available until 12/6. In the lab guide, at the end of each lab, there's a recording of, for each lab that we're going to be doing. So if you're not able to complete this, or you need to leave for a meeting or something else that happened, you can always come back and look at the lab guide and complete it until 12/6. And if you have any challenges there, you can just walk through the recorded demo. Right, so we're trying to make it where everybody that actually attends these lab completes it, because we are really interested in getting feedback to look at work on improving the product itself. Just one comment, the stuff I'll be showing is going to be some stuff that we're looking to include into the product that's there available today, but the environment is running on an older Xanadu release. So you're going to be spending a little more hands-on to get it started. But just note that the future releases and the releases that's available today makes things a lot more easier. So let's start. Now let me just close this piece right here. So ITOM Health Log Analytics is the piece that we're going to be covering today. It's a solution that's very unique in the market. I'm also going to be saying HLA, which is short for Health Log Analytics. So again, most AIOps tools start at alert ingestion, but HLA starts a lot earlier. It's going to analyze raw logs, detect subtle anomalies like anti-patterns, as well as emerging issues, and send these high-quality signals into event management. So you're not just reacting faster, you're seeing problems no one else typically does, especially with traditional AIOps tooling. So I'm not going to spend too much time on this, but I just want to highlight that this is the digital transformation maturity model. It's a good way to assess where you are today in moving from reactive to proactive to predictive IT. Wherever you are in your organization's journey, ITOM can help you progress with proactive automation capabilities. And again, because the solution that we have sits on top of the Now platform, we can unlock a lot of capabilities like creative workflows from an automation standpoint. If we briefly look at the various levels of this maturity model, you can get a sense of where your organization is today and where you need to be. So where does HLA fit in this maturity model? So as you can see, it spans both level 3 as well as level 4. So next slide. So again, before I dive into HLA or health log analytics, let's take a moment to understand, why this matter or why this solution matters. So as you can see in these visuals from recent industry reports, the cost of IT downtime is escalating across all industries. So over 90% of enterprises report that downtime costs more than $300,000 per hour, and almost half of these customers lose $1 to $5 million per hour. In some cases, like finance, automotive, or manufacturing, outages can exceed $5 million an hour. So these are not just abstract numbers. Every alert that goes unnoticed, every log anomaly that isn't serviced in time could mean a lot of lost revenue, as well as lost trust and increased operational risk. So obviously, proactively detecting anomalies can reduce time to resolution, resulting in significant cost savings. So this is where HLA, if you implement it within your organization, becomes a huge game changer by enabling early detection of anomalies, automated log clustering, and faster root cause analysis. HLA helps organizations shift from reactive firefighting to a proactive reliability. So if you haven't seen this before, this is our AIOps incident avoidance model. Most ServiceNow customers start with ITSM, so the motion is incident first and very reactive. Event management changes that. We ingest alerts from all your monitoring tools, then we group them and correlate what belongs together, and then we go out and notify the team responsible for troubleshooting this. And this happens right before it snowballs into an outage. The green window, catch and resolve, is where we suppress noise, reduce ticket volume, and short MTTR. In short, event management turns hundreds of raw signals into one actionable story, so fewer alerts ever become incidents. Log analytics now moves us further left of even the first alert. So what HLA is going to do is going to continuously learn normal behavior and flag deviations before your tools raise alerts. So think of HLA as a smoke detector for your services. It senses trouble long before you see the flames. Those extra minutes or hours give responders time to remediate quietly, protect error budgets, and prevent customer impact. So HLA detects early, event management correlates and routes automation and remediates, and that in a nutshell, is AIOps incident avoidance model in a nutshell. So the next piece, I'm not going to spend, again, too much time here, and this is really the crux of the entire ITOM event management solution. So, so the first part is you started with ingestion. So we start by ingesting signals from your monitoring ecosystem. Again, this is all the various tools that's out there in the market: SolarWinds, Dynatrace. We have webhooks, SNMP traps. You can have email-based ingestion. You can set up custom webhooks if the tool is not supported. So we really can ingest really anything out there. The next piece is the enrichment phase. So in the enrichment phase, we're turning those raw signals and attaching CMDB context to it. If you don't have a CMDB, we can also use tags as well. So things like application services, support groups, business criticality are all automatically added. So we're normalizing the tags as well, assigning impact and map the alerts to business services, giving every event rich actionable context. And this is where the Now platform shines. Unlike point tools, we're not just storing alerts, we're linking them to service maps and the teams responsible in real time. The next piece is on the grouping side, right? This is where event correlation is going to come in. We're using multiple clustering algorithms based on time, text, similarity, service topology, change, data, as well as tags. The goal is to group related alerts into a single incident and identify a probable root cause. Just want to highlight that piece is very critical there, a single incident. So if you don't use event management and you're integrating with these various tools today, every one of those tools are going to create an incident. By using the event management piece, you're going to group and correlate all those tools, the alerts that are coming in, the signals, creating one primary alert, and then setting and creating one primary incident based on the rules that you define. So the value here is significantly reducing the noise and helping teams avoid duplicate work or missed context. This is where you go from thousands of raw alerts to one meaningful signal tied to the actual service. The next piece is, is the respond piece. Once we know what's wrong and who's responsible, we shift to response automation. So we're leveraging, again, the 200 integration hub spokes that we have today. And again, this is from the Creator Workflow business unit to automate these tasks, whether it's collaboration with your teams and Slack and things like that, or remediation with the tools like Ansible, Puppet Chef, or escalation. This could mean reducing the amount of war rooms, time running diagnostics and things like that, again, to help reduce that MTTR and achieving greater ROI on your solution. So where does HLA fit in this equation? So HLA fits in between the enrichment phase and the grouping phase, right? So again, it's going to ingest these raw logs, detect anomalies, and really just services and leveraging the power of the AIOps solution to help you go out and troubleshoot and diagnose this. So to take a step back, let's understand a bit more about logs, right? So when something starts going wrong in software, the first whisper is in the logs. A developer thought the behavior mattered enough to write a message. That's why level 3 folks, as well as product SMEs, always end up here in logs. That's typically where the trail starts. But there's a cache of logs. They don't arrive politely. They come in streams. And each data source type has a unique value. It's right there. So you're seeing all these logs and signals coming in. So logging vendors, if you work with them, they typically size their platforms based on EPS or events per seconds because the volume is the name of the game. On a single collector, these log store systems, they can handle tens of thousands of logs at scale. And then you multiply this across nodes and regions, and basically humans simply can't read the amount of logs that are coming in, basically like a fire hose. So yes, there are logs and they're the right place to look at, but they're also the wrong place to look by hand. These signals is there, but it's basically the scale that becomes the main problem. And this is why health log analytics exists. HLA was purpose-built for its fire hose to learn what normal behavior looks like across a vast, massive log volumes, detect anomalies early, again, before those tools even fire an alert, It's going to cluster related patterns and hand one actionable story to operations. So again, humans decide, machines do the sifting. So I like to emphasize that traditional, again, AIOps tools consume just alerts. HLA is built differently. Its HLA input is different and ingests raw log data and analyzes it in 3 steps. It analyzes the text to identify the important part of the error message and what normal behavior looks like. Then it starts to identify anomalies in the text patterns. The moment they emerge, every anomaly means something else in your IT system. So running different types of anomaly engines allows HLA to extract meaning from these log patterns. And then let's look at a real-world scenario. All right. So before I begin, I want to walk you through a real-world scenario where HLA made a measurable impact. This is based on an actual customer use case in their pre-production invoicing environment. So what you're about to see is just a sequence of events that could have ended in a full-blown fire drill, but didn't, thanks to HLA. So we'll look at what happened, before HLA. At 1834, the invoicing application stops unexpectedly in pre-prod. Next, the monitoring tool finally picks it up, but only created a minor alert. Service status is stopped. That triggers the fire drill. So engineers scramble, the war room opens, and someone finally says, check the logs. Now here's what happens when HLA is enabled and ingesting log data. So first, HLA's anomaly detection kicks in. It's monitoring the logs from the invoicing service and picks up something unusual. It sees an increase in get API errors. This isn't a threshold breach, it's a pattern deviation. Again, that's key, and we'll touch about that a little later. Just a few seconds later, HLA detects that the phrase argument exception, a specific type of failure, is showing up more frequently than normal. A third anomaly is flagged more generic errors than usual in the same service. Now, in a traditional setup, this would be 3 separate data points that's possibly ignored. Now, at 1507, the AIOps engine identifies that all 3 signals are occurring around the same time. And right after that, the AIOps engine is going to group all these 3 signals together into a single alert, tying together time, proximity, log patterns, and affected service. You can think of this as like temporal correlation. So next, instead of waiting for an incident to be reported, event management then triggers the creation of an incident. Automatically, the alert is enriched with root cause data, get API failures. AIOps is then going to attach a knowledge base article that you created, again, if you did create it, troubleshooting invoice API errors. If you had not created it, our agentic AI capability will be able to create a knowledge base article for you. Then the AIOps solution will route or execute the online on-call notification to the support group responsible for supporting the invoicing application. Now the invoicing support group can start their investigation using Now Assist as well as our agentic workflows. So net, HLA found the story in the log data 3+ hours earlier. So the closing here is, this is the power of health log analytics, not just early detection, but meaningful detection, root cause, context, and action before this disruption hits. In production environments, that 3-hour head start can mean the difference between a routine fix and a huge revenue impacting event or outage. So now let's go into some of the details into how the solution actually works. Whoops. So the HLA process starts with data collection and mapping. In this phase, HLA ingests the log data and relates it to an application service and components of the application service. In the next phase, header information coming from the log source is removed, and the raw log data is passed to the data parsing and normalization process. Following this stage, we have data analysis, where anomalous patterns are detected, correlated, and diagnosis is made. Finally, HA alerts are passed to our AIOps engine or service operations workspace and also leverage the capabilities of the Now platform. So let's start with data collection and mapping. So logging agents and solutions add a header to provide important information about the origin of the logged line and can be configured to add specific tags as well as identifiers. HLA utilizes the header configuration to insert tags used to map the log lines to CIs as well as application service in your CMDB. For data collection, we're using Integration Launchpad. Integration Launchpad, if you're not familiar with it, is a unified hub in service operations workspace to view, configure, and manage ITOM Health integrations. So not just logs, it also supports initially events as well as metrics. So it gives us a consolidated view of all the various integrations that we have. For logging integrations, we support push, pull, as well as TCP, UDP, REST, as well as ACCL. So with Integration Launchpad, for any integration, we provide a guided setup. So a guided log integration, we enable a quick setup of log data inputs. Each log integration will also include the setup instructions, understanding the stream status of the log integrations, notify users of errors throughout the setup process to reduce issues, as well as if there's any downstream issues during setup. We also offer a quick and easy win to monitor your ServiceNow instance with HLA. So it's using an out-of-the-box Glide syslog retriever. So what it's going to do, it's going to stream the Glide syslog table, and this is all done without a mid server. It's going to understand baseline normal behavior, and then it's going to raise anomalies as well as actionable alerts before the users feel this pain. So from alert, you can jumpstart into log viewer to see the clustered messages and exact the time span that deviated, then route everything via event management or trigger automation. From a setup standpoint, it's literally just a name, the app service, and optional filters. And it's all available via the HLA Store app. So the next piece is where we go into is the data parsing and normalization. So HLA uses advanced unsupervised machine learning algorithms to identify patterns within the logs and learn the unique behavior using a source type. Lexical keywords such as crashed or failed signal a condition that can merit attention. So this is what a log message looks like. So if you're just looking at this, they are cryptic and semi-structured. HLA is going to start doing its key value stores, basically, of all the different various log types and start to build its own kind of structure here. So to understand this log data, you need to parse or slice the data in a way that makes sense. So HLA is going to do this automatically for you and then figure out what is the timestamp, what is the severity level, and most importantly, what is the message that's coming from the logs. This is where we stop treating logs as strings and start reading them as language. HLA inspects the inner message of each line and looks for risky semantics, verbs like, again, failed or crashed or errors, exception names, and entities such as user, file, or services. It's then going to baseline how often these risk-bearing phrases appear and flag surges even when the exact wording is new. So users fail to log in isn't just a text match. It's recognized as an authentication failure concept with who, what, where context attached, letting operators spot unknown unknowns early and triage faster. So what you're seeing here is HLA's parsing inner message of each log line and feeds it into the message clustering piece. And it's going to group similar messages by extracting variable parts into parameters. So clustering is going to, again, what's going to do is clustering is going to turn noisy one-offs into clean, reusable patterns. HLA abstracts variable fragments again, the usernames, file paths, IDs into parameters, and it's in a group similar message. So you analyze behavior at the pattern level, not per line. So from a username, failed to log into while reading the file path, multiple patterns from a single data input are normalized and clustered. This makes spikes obvious, cuts cardinality, so downstream anomaly detection and correlation work with fewer, clearer signals, and you spend less time reading the raw log lines itself. So in health log analytics properties, the key value pairs are broadly classified into a metric classification of gauge, meter, and ARC, which is automatic root cause. A gauge is a measure of an actual number, like the time taken number in an access log. Meter properties are those that we count, like the number of times an HTTP status code appears in a given time frame, or the number of times a keyword appears, like error and things like that. ARC properties, the automatic root cause, are those that are used as explaining properties, but anomalies for those properties themselves are not interesting. They're used as supporting information for gauge and meter anomalies. Invalid properties are saved but not counted or measured. You will see your extracted properties listed within the source type structure and have the opportunity to change their classification. And again, all this stuff I'm showing you right here is that you're going to be covering this. We'll be covering this in the lab. So I keep talking about this source type structure. So log analysis, search and queries embedded into operated workspace to search logs in alert context. So what is a source type? A source type acts like a blueprint or a schema that tells the system how to interpret incoming log data from a particular technology. As I mentioned earlier, all the various tools send out logs in different various formats. So whether it's Apache, Nginx, Kubernetes, or custom apps, it defines the format, key fields, parsing logic, and classification rules. Think of it as a translator that makes raw logs understandable and useful for downstream analytics. So why is this important? Logs are incredibly diverse. So without structure, we're just starting at unindexed noise. By applying a source type, we turn raw logs into rich, queryable data with extracted fields like timestamps, error levels, host names, request paths, etc. This enables correlation with metrics, alerting, and dashboards, all without requiring the end user to write regex or manually extracting fields. Oops. So next one, data analysis, anomaly detection, correlate and diagnose. That's what we're going to cover now. This is where all the magic is done. So HLA, what it's going to do is identify unusual patterns or behaviors that may indicate potential problems. The correlation links related events across your systems, helping to pinpoint root causes and accelerate your troubleshooting. So let's walk through how HLA identifies issues in real time using different types of anomaly detection engines. So again, unlike traditional AIOps tools that rely primarily on alerts, HLA directly ingests and analyzes logs and gives us much richer and earlier signals. So let's start off with the first one, deviation. This is when a log pattern occurs more or less than expected. It's a volume-based anomaly. Imagine a surge in login failures or timeouts. This may indicate an authentication issue. So HLA doesn't look at the last 5 or 10 items. It compares behavior across longer windows and times. So hours, days, or even the previous week to determine if the current spike is truly abnormal. So again, what this means, if I just see this hiccup, once or a few times, it's not going to see it's abnormal. But if it sees a pattern emerge, okay, this is not something that's happening. So this is where the long-term anomaly detection comes into play, which most point solutions, again, don't support. The next one is new pattern. This is when a new log message structure or text appears for the first time. For example, let's say we suddenly see errors for user Dan and Joe unable to authenticate. That exact message has never occurred before. This could be an indicator of a new application outage or a failure path we haven't seen before. HLA uses engines like Holmes and ELSA to recognize new log structures and classify them as emergent behavior needing attention. The last one, anti-pattern. This is a missing pattern. When something that usually happens stop happening. For instance, maybe user Joe used to log in daily and now hasn't logged in at all for the past 3 days. That drop in activity might signal a user issue, a failed process, or even potential churn in customer-facing applications. HLA treats this as a silent failure, no error is thrown, but the absence itself is an anomaly. So why all of this matters, every anomaly is tied back to business and user impact. By analyzing the logs directly, we extract signals from both volume shifts as well as language patterns, not just predefined thresholds. So HLA is unique in all of this because it runs all three anomaly paths in parallel, surfacing early indicators of issues before they show up in traditional monitoring tools. So what you see here is a grid of log-based anomalies, each with its own time series spike individually. Each one might just look like a blip, a login failure, a canceled stream, a query that didn't run. But that's the challenge with most monitoring tools. They surface isolated symptoms. What HLA does different here is HLA goes further by grouping these anomalies together based on time proximity. So did they happen around the same time? Shared entities? Is the same user, file, query, or volume involved? You can see that highlighted here. Multiple issues are happening at once. A query can't execute, a file write is failing, a user cannot access the system, a volume is full. So what HLA is going to do is going to stitch together all of these and say these aren't separate alerts, but they're all part of the same incident. And finally, alerts generated by HLA are sent directly to event management, where the alert is further enriched. So if you haven't seen this, so this is our ITOM predictive AIOps solution. So where does HLA fit in all of this? So HLA is fit right there, and its core focus is really to look at this log data. So again, we're ingesting all these various streams of data types, events, logs, metrics. Events go to your traditional event management piece, logs go to HLA, and metrics go to metrics intelligence. So again, predictive AIOps begins by ingesting a massive amount of telemetry data, what I just mentioned. Using clustering and correlation logic, it helps identify root cause with precision, cutting through the noise and surfacing only what's actionable. The result, you prevent around 35% of major incidents of P1 and P2 before they escalate, reducing noise by up to 90%. Right, so you see all the clustering pieces, what I mentioned before, and then everything goes out to the end to the outcomes, and then where the automation occurs. So a lot of various pieces, I'm not going to cover all of it because they're focused on HLA. So HLA is just a key component there. There's another piece as well. If you're using Service Operations Workspace, there is a log viewer. So we're going to analyze and search logs directly within Service Operations Workspace. And with log viewer, there's no need to SSH into individual machines. You can run everything within log viewer to search. If you want to look for all the log lines that say error or anything that says warning, you can do it all within the log viewer itself. So I'm going to end there and hand it off to Will, who is going to kick off the hands-on lab.
The lab portion of the program is intended to be self-paced. We are going to have folks kind of walking through doing overviews of each exercise. But if you work better just kind of on your own, feel free to turn the volume down and just kind of dig in yourself. Once you click the registration link, and if you run into any issues getting a lab instance or something confusing in a lab exercise, do leverage the Q&A panel. Depending on your Zoom client, it may not be right down at the bottom of your Zoom session. Sometimes it's kind of congregated under an ellipsis, 3 dots. You have to click on that, and then that will bring up kind of a sub menu, which gives you Q&A. So you may have to search for it a little bit depending on your setup, but do just post in that Q&A if you run into any challenges or have any questions that arise during the lab exercises. So when you click that link, you should get something like this, which will just get your first and last name and an email address. The email address isn't saved anywhere, doesn't get added to a list or anything. It's solely used just that's your kind of token, which ties you back to your specific ServiceNow lab instance. And if you do have any issues with the instance, trouble getting logged in, or sometimes the instances will go to sleep and you'll see your instance is hibernating. Rather than mess around with waiting to wake it up, we've got plenty of instances. You can just go back to this page, enter a slightly different email address. It doesn't even have to be a valid email address. Like I said, it's just essentially a token that ties you to your current student instance, and it'll assign you a new instance. And so that'll bring you to this page. And so this has two important links. One is this magic link, which will just transparently log you in to your student instance. So you don't have to kind of do multiple steps where you go to the instance, type admin, type password. You can just leverage this magic link here. And then the other thing is, this is probably the easiest way to get to your lab guide, is to just click on this URL here, which is going to show up on that instance information page after you fill in this page here. And so just a quick overview of the lab environment itself before we start going into the individual exercises. So, and this is all covered as well in the lab guide for your edification. As Dennis mentioned, this is not at the latest platform and patch levels because there's some lead time to kind of, when we release a new patch level and platform version, we have to kind of massage it to get it to work into this this lab constructs. It's all self-contained and yet fully functional. So this is currently running Xanadu patch 4 with Health Log Analytics 35.1.26 and the November 2024 version of the AIOps experience bundle, which includes event management and service ops workspace modules, alert automation, and more. And so there have been a lot of exciting updates to the experience and functionality beyond what you'll see in the lab. Continually kind of going onward and upward. I'll call out as we go through exercises where there's a notable kind of change that's in the latest version. I'll try and remember to call those things out. So the lab environment itself consists of, it's actually a full-fledged ServiceNow environment that's running inside a little Kubernetes cluster for those of you who are container or Kubernetes aficionados. And then we added a little test workload in the form of something called Pet Clinic, which has a load generator feeding into, well, it's got, so the container, the cluster itself has a load generator, which then feeds into a specific Nginx container that's supporting the Pet Clinic functionality, which then feeds into a Spring Boot middleware running on Tomcat and a MySQL backend. And all of those things are sending their logs into HLA. Okay, so again, anything comes up, please reach out in the Q&A. And in the meantime, we'll start with our first set of lab exercises. Tarne, are you ready to run through 1 and 2?
Yes, right here.
All right, I will stop sharing and Tarne, take it away.
Thank you. Let me go ahead and share. And if someone just confirms that they can see my desktop.
Looks good.
Okay, awesome. So thank you, Will, for just explanation of what the lab is. So we are going to start with lab 1, and I will go over lab 1 and lab 2. I would like to just describe what we are doing so we are not just going through the steps. The first lab is basically generating errors and being able to see the errors in the log viewer. And the second lab is being able to define an alert based on the errors that we see in the log viewer. And so we'll trigger some errors with Chaos Monkey, and then there will be some errors. We will look at those in the log viewer. So if you go to the all menu, which you can find all of the applications in ServiceNow, on the top left side hand. We will start with typing log lab, which will take us to the log lab sessions. And there should be only one record here in each of your instances. By the way, if you need any help for your instances, just put it in the chat so we can just go over that. Or if you have any questions in Q&A, please. So go ahead and click on this one, the record that we have here. And as you can see, this is the activity portion of it. So anything we do, we'll just wait to see that activity log here to be able to make sure that what we did has been just, operated and such. So first we are going to, as Will mentioned, this is a small application with, a web-based application, pet clinic, and it also has a database. So we are going to reset the database, and that's going to take some time to see the activity in the log activity to make sure that the reset database is success. And if you're following your lab guide, it also mentioned here that you should see a message that comes in that says reset database success. And also we are basically deleting a pod for the K8 clinic application. So we should be able to see that here. And then once that comes here, then we will be moving to the next step, which is we're just going to change the user traffic level to medium and then save this one before running the chaos monkey. So let's just wait for a couple of minutes. Sometimes it takes up to like 10 minutes or so, but it should be fast in these instances.
Yeah, it's totally normal for it to take a few minutes because it is actually making changes to the Kubernetes cluster under the covers. And there we go.
Awesome. So you should see the reset database is success. And then from there, we are going to change the user traffic level to medium. And then instead of, we don't want to leave this form, so we just want to save that one. So if you come over here in the gray area bar on the top and right click here, you can say save, which will save this one, but you will still stay in the form. And once we save that, there should be also an entry in the activity logs to just confirm that the load level was set. And it seems that the load level is success. So next we are going to run the chaos monkey. And again, this might take a couple of minutes because we are doing the changes on the live applications and systems. So we'll just wait for that. We're waiting to see an activity log here, and there we go. So chaos monkey success. And from here, so we reset the database, generated some errors. And let's go to Service Operations Workspace. And how you can access that, you can go to all and just type in Service Operations Workspace, or there's a Workspace tab here in the top that you can click on that one. You might have different workspaces. So we're just going to go to Service Operations Workspace here. And what we are looking on the left-hand side is for this icon that says Log Viewer, because we would like to go and search on the logs. So what we did was we generated some errors, and as you can see, there's a query place here field that you can do queries, which we will do that in the next, we will use that in the next lab. And then you can also select the component. So go ahead and select the component, which is for K8 Clinic, Azure All Services. So basically the first component under K8 Clinic Prod Azure. We'll just leave that for the last 15 minutes, and then we'll hit search. So as you can see, there's some logs coming in and from my SQL database. I'd like to see if there are any errors, because that's what we generated as part of what we did for the past step. So I'm just gonna click on 3 dots on the level and says, or basically filtering it. So we just click on 3 dots next to level. I'm just gonna say if the level is error. And once you apply it, you should be able to see some errors. And I believe this is the end of lab 1. And it would be good to follow each of these labs in sequence because some of them are related to each other. So it would be good if you want to follow the labs till end, it would be good to just navigate through all of these.
Yeah, that's a great point, Tarnay. There are some, so part of what this lab environment allows you to do is to inject various types of chaos into the application. And you've seen some examples of that in exercise 1. You may also notice that there's a lot of other buttons up at the top of that lab session record, such as, kill middleware, and each of those has an analog that kind of heals the chaos. So you've got run chaos monkey, stop chaos monkey, kill middleware, fix middleware. And so at the end of the prepared lab exercises, you're invited to just kind of do whatever you want, kind of, choose your own adventure kind of thing if you want to introduce some of those other error scenarios. But it is pretty important that if you do that, whatever you break before you kind of call it a day and walk away from the instance, unbreak whatever you broke. And what that does is that ensures that so when these instances are idle for a period of time, they'll go to sleep. And then when they wake back up, if you left it in an errored state, the instance may not become available for you to log back into. So the instructions in all the prepared exercises specifically have steps that say, okay, now we're going to set it back to a known good state. So as long as you follow the lab guide, you'll be covered as far as walking through the steps in the prepared exercises. But if you do kind of decide you want to color outside the lines, which is perfectly fine, that's just something to be aware of, that, if you break something, your optimal outcome will be achieved by putting it back to a known good state before you kind of walk away from the instance. So thanks for that overview, Tarnay. If we could, I'd like to give folks just like a 5 minutes remaining to kind of get to the end of this on their own. Again, if you're working at your own pace, perfectly fine. Have at it. But we'll just kind of wait about 5 minutes. I've got a little countdown timer running before we go into the overview for Lab 2.
Yeah, before we go to lab 2, I just want to point out that it would be great to go ahead and remove this filter that we put in, because for the next lab, we are going to run a query that if you have this filter, that query is not going to work out because this is, just filtering it based on the level error. So go ahead and remove the filter, and then we'll go through 5 minutes break, and then we'll come back with lab 2. And I saw a question also came in from Hersey Adam regarding the HLA, what type of logs HLA can interact with and where the logs need to be located. I will just add that we have integrations into multiple log management tools such as, Splunk, New Relic, Dynatrace, any logs that you have in your infrastructure, any application type, you would be able to send those to ServiceNow for HLA to do the log anomalies. We are not keeping the logs for more than 3 days, I believe, which we can increase it a little bit, but mainly we're just capturing the information from the logs and keeping those. So ServiceNow is not acting as your log management solution. If you're using Splunk and have all of your logs, you will just do the integration to send it to HLA for anomaly detection, and the rest of it is just we capture those information from it. And in terms of what logs, we can accept any types of logs, structured, unstructured. Obviously, semi-structured and structured are preference, but we are also able to parse out some unstructured logs as well. Will, do you want to add more into that?
Yeah, one thing that I would like to call out is we've recently added support for self-hosted customers with HLA. And so an important distinction between the hosted versus self-hosted is log retention on a self-hosted implementation is completely customer discretion. So if a customer wants to devote lots of storage to keeping more logs than what Tarnay mentioned, by default it's 3 days. It's actually, there's a finite amount of storage set aside for each HLA, each instance that has HLA. And within that, you can adjust the retention for given log sources. And so if you turn one up, then it may actually, decrease the retention on other log sources based on the amount of storage that's being used. Whereas if you're self-hosted, it's completely customer discretion. And then let's see. So there was something about where the logs need to be located. Yeah. So when we get into the administrative experience part of the labs, I can kind of show just a list of all of the available, what we call data input types, which is the different ways, the different transports that we allow for ingesting logs. It's really limitless, because if we don't have one specifically for a given log provider, you can always go with a REST or a TCP based data input, which it'll just take a payload and feed it into HLA. Yeah, and KP was calling out the fact that for the anomaly detection, the machine learning engine, which sometimes you'll hear it referred to as occultus, which is just kind of the name of that bespoke machine learning engine that's doing all of kind of the magic of correlating and parsing logs to determine anomalous log entries. It's basically turning that log data into metrics, which are then stored in a dedicated time series database. And so it will keep track of, anomalous log behavior even after the actual raw log data has aged out. So it may not be visible in the log viewer that you're seeing here, but it will still, the kind of the underlying metadata that describes that particular log pattern is preserved for it's really preserved in perpetuity, but it's constantly learning. So it's not, you're not going to see the system call out, hey, this thing was different a year ago, because it's going to be continually learning what's considered to be normal log traffic. Okay, and our timer for lab exercise 1 has expired. So Tarane, you want to go into exercise 2?
Yeah, let's do exercise 2. So for exercise 2, we are going to define an alert. First, we want to go ahead and filter. So if you're in log viewer, just say here, we are going to continue from here. Just make sure that you're clearing the filter from the level, so it's showing all of the logs. And I'm going to just filter the logs based on status 500. And the component that we are going to use is the Spring one. So all the way in the bottom, it says K8 Clinic Prod Azure Spring. You can keep that last 15 minutes and do a search. So as you can see, it's searching through the message field, looking for the status 500 and highlighting the search that we are looking for. And then from here on the top right-hand side of the page, there is a button for defining an alert. So we're just going to hit that one, and we're going to define an alert based on the search that we had there. This just makes it easy instead of starting an alert from scratch. This would be just an easy way to filter those logs, which will carry the query into your form with the component and all of that information. So you just need to give it a name. So let's pick that information from the lab guide. The name is going to be Spring Error Alert. We are going to keep the state as enabled. We are going to just copy the description, which is an alert for Spring errors, and keep the rest of the information here. The only thing that you need to change is the hit count is going to be 0, and then the time period is going to be 1 minute. So we are looking to define an alert that for every minute, if there's a status of 500 in the logs for this component, we want to raise an alert. And just double checking to make sure I have everything. And then we'll say save. Doesn't show anything here, but it's saved the logs. So, and again, it might take some time for this to show up, but let's take a look at the express list. So if you pick the express list from the left-hand side, this is where you can see the list of all of the alerts that comes into your system. This is usually where the operators go to triage the alerts, get some information regarding, the grouping. So the number that you can see in front of each of these alerts are the alerts that are grouped together. So for example, this is the primary alert that came in, and then there are 5 separate alerts that came in as part of the related to the primary one. Then you can see where is the source of information. It can be multiple sources. So you can have a group of alerts that 2 of them are coming from HLA, one is coming from Dynatrace, Datadog, like different sources. And that's where we were talking about the event management correlation and grouping, and that will help you reduce your noise in the system. And also for each of these alerts, we only create one incident. So if you click on this one, you would be able to see that these alerts are grouped together, and there would be one incident for each of those created. This is partly new because we just created, and it's a warning, so it didn't create an incident for that. But from here, what we are looking for is just looking at to see if we can see the alert came in. You can change the timeline of this last 24 hours to all time and see if you can see that, or you can also have the option to trigger it based on or filter it based on the custom time range. And then I don't see it here, but let's go ahead and say spring error. Let's see, filter it. And again, sometimes it takes some time.
Yeah,
Fred.
it can take up to 20 minutes for that, because basically what you're doing is you're defining that alert as it's kind of table stakes for any kind of log alerting tool, right? Is just being able to specify a query and saying, when you see something that matches, here's what I want you to do. In this case, we're telling it to create an alert within event management. So it's kind of taking that definition, sending it to the machine learning engine, and so it's got to ingest that and start acting on it, which can take some time. The instructions in the lab exercise actually don't require, that you see an alert get generated in order to kind of get all the way through that particular exercise, because exercise 3 is going to spend some more time walking through express list, digging into some example alerts and doing that portion of kind of the experience. So don't get too concerned if you don't see the defined alert start to generate actual alerts within the time for exercise 2. There are some additional queries to try in the log viewer that are part of exercise 2 as well. So just to give you some examples of what else you can do. This is especially compelling now that we can ingest your ServiceNow platform logs kind of transparently, and it's actually enabled by default now if you're at the latest platform and store app versions for HLA. And so now, instead of having to go through list view to try and filter and search your glide logs, you can actually use that same log viewer mechanism. So that's an improvement that HLA brings, almost like a secondary value that HLA brings to the table just by allowing you to peruse your glide logs using log viewer now.
So yeah, as Will mentioned, it might take some time for that alert, but we don't have to have that to continue the rest of the labs. I just pulled a couple of these because these are all good examples, and you should have it in your instance as well regarding what we wanted to show as part of lab 2. And I grabbed a couple of alerts that each of those have different anomaly detections that we can go through. So if you just open one of these that says no data is streaming from Spring, you can see in the anomaly section, you can see that it says data stopped streaming. So this is one of the anomaly patterns that Dennis was showing us regarding, how HLA identifies patterns. If the data was streaming and now it's not coming from this application, this would be an anomaly pattern for HLA to raise an alert for, and this is what you can see for that. And it also shows the views surrounding logs for that. So if I open and I want to just continue my investigation regarding what's going on, then you would be able to see the surrounding logs. And again, this might be, an instance that you need to change stuff and such. So let's see if I can show you the surrounding logs in another alert. But another anomaly pattern is the behavior detected is the events were coming in and now suddenly it dropped. So this is anomaly that, 71% decrease in log volume, and HLA will create an alert for that one as well. Let's hope that this will show up. Yep. So you can see these alerts, these logs surrounding those alerts that are coming in. And, as part of the investigation for the operators, they can look into these and see what's going on. And the third pattern was the low volume logs appear more frequently. So this is where typically the logs weren't active, and now I see a jump in the logs. So this might be something that's worth looking into. And again, you can access the surrounding logs for that. So just showing how HLA identifies those anomalies, but then attaches it to an alert, create an alert, and it also provides some context around what's going on so that you can do some investigation around with other information, such as, what is the CI that is impacted? What are the impacted services? If there's anything from probable root cause perspective, or provide some meaningful insight from logs by capturing the properties and such from what's going on from, the IP status code and such. So all of these are just enrichment to the alerts that are coming in the hope of reducing the MTTR. And I believe this is the end of lab 2. Will, back to you.
Thanks, Tarane. Yeah, the whole surrounding logs thing, I think that's really a callback to the fact that we're running Xanadu patch 4. There were some kind of known idiosyncrasies with the surrounding logs panel. So in your lab environment, as a workaround, if you're browsing alerts, you hit surrounding logs and you're not seeing any data, you'll have a button that will take you to Log Viewer that you can use as well to search through logs. There was some kind of time zone stuff I know in earlier patch levels, such as the one we're on now in the lab environment, which caused some strange behavior when it came to viewing logs. It would kind of cross the time zone. So if your time zone was one thing and the instance time zone was something else, and the time zone or UTC that was being used by the raw logs, if they would all kind of interact and result in sometimes some edge cases where it would fail to bring in those surrounding logs. The other curveball that we throw in the lab environment is, because this is all running kind of in ephemeral compute resources, whenever the lab instance hibernates, all of the raw log data gets wiped out because it's not kept in persistent storage. So that is, if you do want to play with this environment tomorrow or the next day, it's expected behavior that if you go into Log Viewer, you're not going to see historic data going back to today if you're looking at it after hibernate and wake cycle occurred.
So we'll
Okay,
stop sharing. And
sounds good. Let's see. We've got 2 minutes remaining on the countdown timer for this exercise. Let me see. Here we go. I'll bring up my screen. And the next exercise we're going to go through is just going to be going a little more in depth into exploring the alerts that we've generated. And then a very important step at the end of exercise 3, we're going to kind of set everything right. We're going to turn off the chaos monkey. We're going to set the user activity level back to low because we're using kind of shared CPU and memory resources on these lab instances. And if we're generating high user traffic in the example app, that can affect the behavior when we're doing some of the other lab activities. Just counting down to the last minute. Okay. Okay, again, don't be shy about throwing things in Q&A. Appreciate all the gurus keeping on top of that. We've got no outstanding questions. Okay, so that's the end of our appointed time for exercise 2. So we'll go right into exercise 3 with an overview. And just to call out, when you look at the lab guide, you'll see the YouTube URL at the bottom of each one. So if you need to revisit or want to kind of zoom in on a particular aspect of any exercise, you've got a full video walkthrough for each lab exercise that you can refer to at any time. Just a quick shout out that if you've got, coworkers, teammates, etc., who you think would benefit from this lab content, it is available so that any of your account teams out there can arrange to deliver this lab content directly to just you and your peers. You just need to touch base with your account team, say you're interested in the HLA workshop, and they can work with us to get something scheduled so that you can have this kind of all to yourself. Okay. So now lab 3 is kind of expanding on some of the things that Tarane just showed as far as working with Express List and navigating through triaging, providing feedback on the alerts that you obtain from HLA. And for those of you who are already using event management, this will probably look somewhat familiar because it's based on once HLA does its magic, it feeds into event management. So the user experience will be very familiar to anyone who's already using Service Operations Workspace and Express List to navigate event management. So the exercise starts by going to the Service Operations Workspace, which is conveniently available under the Workspaces submenu, and then clicking this icon here, which takes you to Express List. And so here, for example, you can see I've got a spring error alert from my alert that I defined when I went through exercise 2 a little while ago. So that's just an example of what that will look like. If you've got that alert, you can certainly drill into it as we progress through the exercise. So we just do some quick filtering just to kind of filter out some of the noise that can appear in the Express List. And so we go to the source and make sure that log analytics and group alert are the only two things that are highlighted. And then under configuration items, we focus on our example application service from our sample application. We make sure we don't have anything in the search window. And then the lab guide will kind of like if you're not seeing alerts, it'll walk you through some things to look at to get an idea as to when you should reasonably see some alerts by looking at that activity feed. So if we look here, this activity feed is useful because it'll show us when we kind of kicked off different failure scenarios. And so we can leverage that to kind of get an idea, okay, look at this timestamp, calculate, 20 minutes from there. And that's when we would expect to start to see resulting alerts from injecting those types of chaos scenarios into the app. So in this case, I've got a few. I went through the first couple exercises as we were getting started. So the next step in the exercise is to pick one of these alerts, and what we want to select is an individual alert because that's how we see the specific HLA decorations and enhancements that get placed into the alert record that will be different than a standard event management produced alert. So I'll just pick the one from my defined alert to start with. I do encourage you to kind of pick a couple different ones because depending on the nature of the alert, you'll see some different kind of decorations and modules within the alert record itself. And so again, we've got the view surrounding logs link. And if that kind of doesn't come in with any data, you can always, don't be concerned. That's, like I said, kind of known errata, which is resolved with the latest patch levels. You can also click log viewer to go into the full-fledged log viewer with kind of a built-in, it basically kind of turns that alert filter into a specific query that will pull in pertinent log data for that alert. Do try your best to use the Q&A just because I know that's where the gurus are focusing their attention. So if you put something in chat, there is a chance it may get missed or just not noticed in a timely fashion. Okay, so we viewed our surrounding logs. There is kind of a note in the lab guide that just mentions the fact we're using ephemeral storage for the raw log data store. So it is going to be normal if you revisit this after your instance is hibernated and you've woken it back up. You will be limited as far as you'll only see raw log data from the time that instance booted up. We do have some automation around the lab instance itself that will kind of feed in some example data. When it first boots up, it'll kind of start that and generate 24 hours worth of example data just to give you a little bit of data volume, log volume to work with. So that will populate within about an hour of the instance waking up. So you will have that kind of ability to go back to a few previous hours, but it's not going to have any raw data since the actual raw data since the instance was hibernated due to inactivity. Okay, so the exercise is going to take us back to the overview tab. And again, the nature of this graph will depend on the specific type of alert that you're clicking into. There's an appendix in the lab guide, which also walks through some different examples of types of anomalies and the resulting alerts, which can be produced. The expanding the impact tab, since this is tied specifically to an application service, that's going to show up as the configuration item. And if the config item itself is an app service, you're not going to see it again here as an impacted service. So in a production implementation, this config item would be potentially a server or a Kubernetes pod or a Kubernetes replica set. And then the application services and service offerings that are supported by that config item would show up here in a in something other than the fairly simplistic example that we're running in this lab environment. Okay, so we've gone through cause. And then in terms of pulling out meaningful log properties, that's going to be visible from a more organically generated alert. Okay, let's see. Cause. So again, we walk through the process of defining an alert because it's kind of table stakes. I mean, that's kind of a very basic log alerting capability that any tool that works with logs is expected to have. The real special sauce of HLA is the fact that you don't have to define alerts. It is constantly doing kind of real time, unsupervised analysis of the full bulk of your raw log traffic and then identifying where it sees anomalies. So when it's doing that, how do you tell it? How do you kind of give it a score? How do you tell it, oh, this good job, this is really anomalous, you need to raise that up every time, or semi good job, this is of concern, but not at the current level. I want to know when it gets worse. Or, hey, this is a red herring. It's not an issue at all. And that's accomplished via the apply machine learning feedback button. And so the exercise is going to walk you through using that just to show you what it allows you to do and walk through the mechanic, which is really pretty straightforward. So it gives you these options. The raise option is to add another standard deviation to the threshold that it is set internally before it actually generates an alert for this particular behavior. So that's hey, yeah, this is of concern, but not at the current level. Let me know when it goes up another tick. And that's what the raise feedback tells it to do. There's two mute options. One is to just mute this specific metric, which again, HLA is taking log patterns, turning those into metrics, and that's what it stores for historical reference and how it knows that things are changing. And so if you want to say, no, this is never going to be a concern for this particular component, then you use this option here, mute alert metric. If you want to say, don't ever tell me about this, even for new components that I haven't even added yet, that's what the mute alert metric for all components will accomplish. And all of these things, it just stores records in a table for these exceptions and adjustments. And you can go revisit those at any time, clear them out. You can also clear out feedback from here. So in the lab exercise, we walk through marking a metric as significant just to show that changes the button. So now we've provided feedback. And so now we don't have an option to add more feedback. It changes to a restore, and that will basically undo it. But it's all stored in tables on your instance, so you can go and kind of peruse them over at your leisure. You don't necessarily have to go back to the alert that was the kind of the genesis of that machine learning feedback. You can get to them directly as well. So kind of continuing on the user experience, the operator experience journey, there's a button on alert records called Launch Playbook. And what that'll do is that adds this tab, which takes you to the automated and semi-automated actions that you're able to execute. And so this is tying directly into standard AIOps type stuff, where if you create an alert automation that contains a filter specification that matches this alert, and then you add, I want to run this, I want to generate an incident, I want to send a webhook, I want to run a subflow to that alert automation. all of those options will appear here if you specify them for manual execution. Specify them for automatic execution, they'll just run. The general progression that we see is, crawl, walk, run. They start out being manually triggered, and then once there's a comfort level, that's when the training wheels come off and it gets set to an automatic mode, and then you've got self-healing. Okay, so we've done our feedback. We've checked out our playbook. Okay, and so that's the end of the kind of the harbor tour of ExpressList and looking at alerts, especially and calling out kind of the special additions, most notably the identified issue and anomaly content. One big change that came out earlier this year is this anomaly graph is now visible directly from ExpressList. You don't have to drill into the alert record for that anymore. So what I mean by that is when you click in onto an alert from ExpressList, it brings up this side panel, which gives you a bunch of different tabs depending on the nature of the alert. So the latest version of this includes that anomaly graph directly here. So you no longer have to do that slight context switch and drill into an alert record in order to see that. So super important at the end of the exercise, it's going to have you go back to your log lab session record. And we're basically going to turn off the chaos in order to save some cycles, some CPU cycles and resources within your lab instance when we get to the next set of kind of admin experience lab exercises. We want to kind of preserve some of those system resources so that those exercises will run optimally. So just walking through, the first thing we do is we click the Stop Chaos UI button there. And then similar to when we kicked off the Chaos Monkey, we will see an update in the activity feed. Okay. And so we can see that Chaos Monkey was successfully stopped here. And this is an actual running workload, so it may, maybe that quick. It may take five minutes. 10 minutes is the longest I've ever seen it take. That's an outlier, but just try to be conservative when we set expectations in the lab guide. And then the other thing we do is we're going to set our user traffic level that's controlling the load balancer, the load generator that's built into the example application. So we're going to set that to low to just minimize the log traffic, and then right click in the header and click save, which will trigger an update to the cluster for that. Okay, and so now we've successfully set our load level back to kind of the low value. So we've reduced the amount of user traffic going into our app, which will allow us those precious CPU cycles to perform the rest of the exercises. So what we'll do is I'll set a timer for 5 minutes and let folks use that time to either finish up the operator experience labs if you've been following along, and otherwise take some time and take a break if you like, and then we'll re-engage and start the administrative experience exercises. So now the next set of lab exercises is looking more at the administrative side of setting up HLA. And we'll show kind of the different integration points where the customer has the ability to kind of tweak what the tool is doing as far as how it's interpreting given log formats. Also, I did see the question about how do we manage sensitive information that's going through the tool, and there's a specific exercise that touches on that as well, using what's called the pre-processing capability. And then there was a question early on about what log formats are available, what do we support, how do we bring the logs in, so we'll touch on that as well. So we're starting with ingestion, bringing the log data into the platform. And I guess just to make sure that there's a good understanding of where the log data goes, because for those of you who worked in the ServiceNow platform proper for a while, it probably doesn't strike you as something that's capable of processing tens of thousands of log records per second necessarily. And you'd be correct in surmising that. We use a dedicated set of kind of additional resources, either within, the ServiceNow data center or in the customer data center in the case of self-hosted, to do the heavy lifting of ingesting the logs, performing the analysis, and then when anomalies are discovered, that's when there's interaction with the ServiceNow platform itself to register those anomalies and generate alerts and such. Defining those data inputs, those ingestion points, that is accessed within the platform itself. And that's going to be the first portion of what you're doing in exercise 4. And so we start by navigating to, under Health Log Analytics, we navigate to the data inputs. And a data input it's an entry point for log data to either get pushed in from the log source, or we also support various pull methodologies, which can do periodic polling of things like S3 buckets that are storing log data, various log management solutions that have an inbound API that lets you run queries and pull log data. So just to get a little taste, and again, this is an area that's changing pretty rapidly. There's loads of additional out-of-the-box data input types that are supported at the latest patch level versus where we are with this Xanadu patch 4 version. But just to give you a taste as to the variety of log sources that we support out of the box. And you can click into this yourself in your instance and see that we're in the process of kind of migrating this experience from this kind of older legacy setup to this one here based on the integrations launchpad experience from within ServiceOps workspace. And so you'll actually get a taste of this in exercise 7 when you're going through and enabling the glide syslog ingestion. But we've already got visibility from integrations launchpad. So if we want to see all of the pull log integrations that are available, here they are. And then on through the different options, including those that are driven by our agent client collector for log analytics, store app, which uses the unified agent client collector agent to pull logs directly off of hosts that are running our agent. Okay. So for the specific lab exercise, we're going to be focusing on this Minikube Fluent-D data input. That's what we've kind of created as part of our sample application, which is responsible for streaming the logs from all those little containers that are running the pet clinic application into Health Log Analytics. And so when we click into it, we can see up here that it's expecting the traffic to be in an rsyslog format. Again, that was just our selection. There's no requirement that your log traffic be in any particular one format. We can literally pull in whatever type of log streams you've got in your environment. And so the exercise is going to basically just have you check your streaming sources. So there's a streaming source that corresponds to each distinct origin for a set of log traffic. It'll give you some rough numbers as far as average raw log lines per second and then pre-processed log lines per second. The preprocessor is something we're going to dig into next in the exercise. So you should, when you're doing this on your lab environment, you should see this in an active state. There's some startup scripts that attempt to kind of take care of all that, make sure it's all shipshape. But on the off chance that it's not active for whatever reason, this stop data input button will be a start data input button, and that can be used to activate the data input. And so once we've verified that our data input is active, that's when we click this related link called Go to Preprocessor. And so the preprocessor is a record which defines how you want the mid server, which is so log ingestion. A lot of the data inputs leverage a mid server as kind of that intermediary where it's pulling the log data and then it's sending it into the HLA components within the ServiceNow data center or the customer data center. And the preprocessor gives you the ability to say, hey, I want traffic that looks like this to either not get sent to the HLA components or be transformed in a way that obfuscates any HIPAA or PII that is sensitive, and you don't want to have to worry about it living somewhere on a solid state drive in a ServiceNow data center. And so the way that's accomplished is via this custom JavaScript function. And so in the exercise scenario, your company has decided it doesn't want DNS lookups to be logged. It doesn't want those IP address and hostname information to be sent to the ServiceNow data center. And so to do that, we're going to just implement some JavaScript code that just drops any log coming from the container named core DNS. And so the way we do that is we're leveraging the ability to create function templates within HLA. And we give you a predefined function template called HLA lab preprocessor template. And that's just going to paste in some JavaScript code that'll do some regular expression matching saying, hey, if this has a Kubernetes block and the container name matches core DNS, then I'm going to call this drop method. And so a recurring theme that you'll see in the various records that are used to tweak the HLA behavior is you'll see a refresh samples button, a publish button, and a test button up at the top. And basically what that lets you do is validate that the adjustments you're making are going to produce the outcome that you desire. And you can do that by either selecting raw input samples, which are automatically accrued by HLA to represent example traffic that's been coming in from this log source, or generate your own manual sample. If you have a specific edge case you're trying to address, or you just know what kind of log traffic you're interested in pre-processing and don't want to wait for a sample that looks right to come in, you can populate it here. And the DNS, it just so happens the DNS lookup is kind of hit or miss. And so in the lab guide, we provide an example manual sample that you can paste in. So it's always kind of a good idea to click that refresh samples button on any of these HLA config pages, just because that ensures that you've got kind of a current set of samples from your data. And then if you did have a particular log sample that kind of came in organically that you wanted to select, it's going to constantly store 100 based on, it'll just grab the next 100 from after when you push the button. And then if there is a particular one, you can just select it by clicking on it there. In this case, the lab exercise is going to have you copy a example log payload from the lab guide. And that's that is one pitfall sometimes people get into. Sometimes there's a little issue with copying and pasting. So you want to make sure that you don't see any carriage returns, new lines in here. So in other words, like if you paste this in and you see that it like goes to the next line like that, you want to get rid of any of those extraneous new lines because that'll affect the parsing. And then the other thing that I've noticed is that sometimes there's a weird thing with the mouse focus where, so once you've got a manual sample, you click this go button to actually evaluate that specific sample. I've noticed sometimes it doesn't actually register immediately. It didn't save my preprocessor. There we go. So if you click the go button and down here, you don't see this is dropped true, just click it again. It's just kind of a weird edge case we've seen from time to time. So I just like to give people a heads up and just don't be concerned if it doesn't work the first time, just click it again. And so this kind of just demonstrates a very simple pre-processing case where you're saying, if it matches this kind of condition, just drop it and don't ever send it to ServiceNow. That being said, sky's the limit. You can create whatever JavaScript code you want here. This is all running on the mid server. So it ensures that if you want to transform or drop a payload, it'll happen. The mid server won't ever send it on to the ServiceNow data center. And then if you want to run a bulk test that basically evaluates this code against all of the 100 samples, that's where this test button comes into play. And so that essentially sends all those samples through the preprocessor and then just gives you it's going to show you if there were any failures across the board. The only log record that it will report actual results for in the outcome tab are going to be the one that you selected here when you click the test button. So that's kind of the difference. If you want manual sample, you use the go button and that'll report the results down there. If you want to test everything that's in the sample bank at the moment, you click test and that you'll see if there were any JavaScript failures here, but the outcome is going to be whichever raw sample you've selected in this field right here. And then once you're happy with the outcome, that's when you click publish and that actually sends that out to the kind of commits it into the HLA engine itself. And that concludes exercise 4, which focuses on ingestion and pre-processing. Let's see where we are. Lab 4. So lab 4, we have kind of benchmarked at about 12 minutes. So I'll just set another 5-minute timer for folks to wrap that up. And then we'll resume. Okay. Okay, moving on to exercise 5. So now that we're ingesting and performing requisite pre-processing on our log data, the next step is to pull out a couple specific details that help us to characterize the log file format. That way, if you're pulling in log data from a single source, but in multiple formats, you can slice and dice those and have them be parsed appropriately. This also provides the first ability to specify a service instance or app service that ties back to this log data, and then to further break it down into individual components. So we'll start the exercise back at the data input list. As with all other things in ServiceNow, there's all sorts of ways to get to a given destination. So we selected one, but there's multiple ways within the product, whether it's related links or favorites or good old, I heard a new nickname I hadn't heard before, left nav, for the traditional kind of left side navigation menu. So yeah, we'll go to the data input list, select our Minikube FluentD data input, and then we use the go to mapping related link. The mapping form is where that's where the HLA components actually start dissecting the log data. And it takes the log payload and elicits 3 key values out of it. One is application service or service instance. And then, so within that, it then breaks it down into one or more components. So in the case of our example application, we've got different tiers. And so we're going to break it up into Nginx, the load generator, the middleware, the Spring middleware. And in our case, we're just using JavaScript code to break that out based on Kubernetes metadata. But it can be done any number of ways, whether it's by looking at the log payload itself, or just by virtue of the source, you can just hard code it to a specific value. In fact, when you create a data input, part of what you're populating is a default service instance, which is what it will use if it's not given alternate values from the mapper record. And so we've got service instance, we've got component, and then source type that's the HLA term for a file format. So for each different format of log data, you're going to have a different source type, but you can have those be common across multiple service instances and components. So you don't have to create a separate source type just because you've got 5 apps that are using Nginx, for example. And then it basically conglomerates the component and source type into what it calls a source. And so it's important to mention that HLA will apply some reasonable defaults. Like I mentioned, the data input requires a default service instance value be populated. And then it will elicit, based on the contents of the log data itself, it will pull that out and provide some default values. So you can start with HLA without having to put this together. But then generally what we find is to get at that last yard across the goal line, some amount of tweaking in the form of some JavaScript in the mapping record is generally put to use. In the lab exercise itself, we're going to build on the JavaScript code that's already there by pulling in the lab mapping template. And what that's going to do is, in addition to what was already getting pulled out, it's going to look for things that are running in the Kubernetes namespace, which is named kube system. And that's the Kubernetes namespace that's running all the supporting functions that just kind of keep that Kubernetes cluster running. And so the template that we pull in as part of the exercise has some logic that says if the namespace is kube system, then generate component value and a source type based on that Kubernetes metadata that's contained in the log entry. So then the exercise will go on to freshen our samples with the refresh samples button. And then once we've got fresh samples, we'll actually just go through the exercise of clicking the magnifying glass and selecting an example log record that appeals to us. Completely arbitrary. There's no requirement that you select a specific one. The other thing that you'll notice is that it's already pulling out the source type and source values and populating those with the sample record itself. So with the data input mapping record, it actually is working with a sample set of 1,000. So it's pulling 1,000 records out of the log stream, starting with when you click that refresh samples button, and then it takes the next 1,000 records that are coming in. So I'll just select a likely looking log sample. And again, you can leverage the manual sample option just like you did in the preprocessor side. It's all a consistent experience with these different HLA configuration panels. Now, since I'm not using a manual sample, I'll just click the test button, run through all 1,000, and it'll aggregate things. So it'll say if there were any errors in JavaScript code or any log entries, it was unable to map to those 3 key service instance component source type values. That would show up here. It'll tell you how many individual source types and therefore sources it pulled out. The outcome key value mapping value, that's going to reflect what was pulled out of the specific selected raw input samples. But then you get some additional aggregated data. So it'll tell you what source types it pulled out, what the corresponding sources were. If you do see errors, you'll get specific error messages in the errors tab. If any log records were unsuccessfully mapped, you'll see that here. The different source type structures that were pulled out will show up here. So it's basically, this is how you see how the log traffic is being parsed and split into different source type structures or log formats. And so we didn't get any errors, happily. So now that we've got our adjustment in place, we can click the publish button. And again, that pushes it out to the HLA backend and commits it into the system. Until that publish operation is performed, the changes that you see, even if you save the record, if you save the record here, those are not going to actually have any material impact on the log processing until you click that publish button. And hopefully see that publish completed successfully banner across the top. Okay, and that takes us to the end of exercise 5. Put another 5-minute timer up just for folks to finish up before we move to the next one. And again, just to emphasize, for in case anybody missed it or didn't notice, when you go to the end of a given exercise in the lab guide, you'll see a link for a video walkthrough so that if you're working at your own pace or you want to revisit, you've always got the option of watching somebody walk through these exercises on YouTube. Welcome back from our short interlude. We're in the home stretch as far as prepared formal exercises is concerned. Moving on to lab 6, we're going to talk about and experience some source type structures. And so now that we've ingested our log data, we've kind of taken that initial pass to split it up into that service instance component and source type tagging, if you will. Now we dig into specific source types, which again, a source type is HLA taxonomy for a file format. So this is where we really kind of look at what HLA did with that file format. HLA understands a lot of different common file formats natively. So it will, in many cases, do a really good job of giving you a first pass of splitting things up, slicing and dicing, pulling out the important elements. The source type structure record lets you inspect that, test it, and then adjust it as need be. So the exercise is going to start by going to the source type structures list. And then we'll take a look at a couple of the source type structures that we've defined within your lab environment. The first one is going to be the Kate's Clinic -Spring source type structure. Okay. And so right off the bat, we'll click refresh samples to make sure we have a fresh set of log samples. And then similarly to what we did with the mapping record, we'll click the magnifying glass to pick our favorite out of 100 recent log samples. And again, probably becoming old hat at this point, but similar to the other HLA config records, we've got the option to test a manual sample here. In this case, we're working with our kind of organically grown samples. And so we'll just click the test button to see how our source type structure is getting broken up. And again, similar to the other records that we've looked at in previous exercises, we've got aggregations here, which will call out if we had any timestamp extraction failures. In other words, HLA was not able to figure out where the timestamp lived in any of these samples. Similar for severity extraction and message extraction. And those are kind of the key elements that in most cases you want to see HLA successfully pulling out. You want to know when something happened, what the severity was, and what was the actual content of that log message without kind of the meaningful content. So in other words, ideally you'd want the message value to not include the other stuff like the severity and the timestamp, just to make it easier to turn that into a meaningful metric. So then in the exercise, it's going to have you scroll down to the related lists, and you can see all of the key value mappings that got pulled out. And then you can tell which ones HLA did on its own by the extraction type being automatic extraction. And then you can tell which things were driven out of the script in the middle by the extraction type being designated as script. And then each of those kind of key pieces of data, those key elements are going to have a label assigned. And that's how HLA kind of knows, okay, this key value actually is the message, and this key value is the timestamp, etc. And so our test run was error-free. We can see we've got these three labels are kind of the key ones, and those are getting assigned. So we can click publish. And that will, in this case, we didn't make any changes, but if we had made any changes, the publish would be the final step to make sure those changes are committed and acted upon by HLA going forward. So now we'll go back to the source type structures list and look at the Kate's Clinic-Nginx source type structure. Again, very similar set of steps. We'll refresh the samples to make sure we've got a current set. So one thing to note in any of these exercises, if you don't see a raw input sample right away, sometimes there's some processing delay. You can just refresh the page, and that should bring in the raw sample data into the form. And now again, we'll click test to do a bulk test against our custom JavaScript function. We'll see the aggregated results here. Thankfully, again, no failures. If any get dropped or just produce JavaScript errors, you'll see those on this side. And also, you'll see specific errors on the errors related list. So, I mean, these instances are yours to play with. If you want to kind of simulate errors or cause errors, if you're comfortable enough with the JavaScript to kind of throw some curveballs in there, feel free. As you would expect, the publish button won't work if you're getting JavaScript errors back from the code. If you can't compile the JavaScript, it's not going to let you push that bad JavaScript out. And so again, we can see our three key labels are being assigned to some key value pairs that are getting pulled out. In this case, only the severity is coming from a script. The rest is just automatically getting, it's severity and message are coming from the script. Timestamp is getting automatically extracted. And so one thing just to call out, you've got this reset learning button. So that could be used if there's a change to the file format and you want HLA to take another stab at kind of automatically parsing through it. You can reset the learning flag. It'll go back into learning mode. It needs to ingest 100 log records. It will kind of relearn, take another stab at automatic parsing, and allow you to see those results and then apply whatever tweaks that you would like to. One thing to call out is in the case of a very structured log, such as what we get from Nginx, it is actually an option to forego the message key value and label instead, because it's automatically going to pull out things like the URL and the HTTP status code, which there's generally not a lot of freeform text or variable text in Nginx log. It's generally just comprised of some very specific and predictable elements. And so you do have the option of just omitting that message and just letting it pull out those supporting key value pairs. And it can generate anomalies based on that instead of the message itself. So there is flexibility, and that's part of the reason that you've got these entry points where you can ultimately control what it's doing with that log data. Okay, so we had an error-free test run, so now we'll just publish that back out. And then the exercise concludes with just going back to our log viewer and just observing that we're getting log data carved up as we would expect. So we go to the log viewer, select the Nginx component, And let's see, we'll select last 15-minute time range and do a search. And, just observe that we've got timestamps getting pulled out. We've got the component and the service instance being correctly identified. The severity or the level is coming in and getting parsed out, as well as the individual message. And just, as I mentioned, ideal message processing is really to pull out kind of the nugget of information. So kind of an improved implementation of this particular parsing setup would be get rid of that timestamp, probably get rid of the IP address, and instead put that over into the host value to just kind of make it more granular. But again, it can be done iteratively. It's not an absolute requirement. HLA can work with whatever kind of patterns are present in that message payload. So after we've looked at the Nginx, we'll look at the Spring component because that was the other source type structure that we explored. So we'll select the Spring component, do a search of that. And again, just observe that things are getting pulled apart and populated based on the definition of that source type structure. Okay, that concludes lab 6. I'll just put another 5 minutes on, and then we'll wrap up the exercises with lab 7. Okay, and we're back with lab exercise 7. Just a quick shout out. It looks like the invite for this workshop went out with a 2-hour duration instead of the intended 3-hour duration. So really apologize and appreciate the folks that have hung with us, even though the invite may have only been for 2 hours. The one I got as a host went the 3 hours that it was supposed to. So I was not aware that at least some people got 2-hour attendee invites. So really appreciate the folks who have hung with us if that was the case for them, especially. Okay. So the last exercise is just going to show how, and it's actually a little bit dated at this point in that what we're going to go through actually now happens automatically when an instance gets updated or if a new instance gets provisioned with HLA and it's at the current store and patch level. So we'll kind of zip through this quick so that Dennis can get to his closing remarks. So the exercise starts by going to ServiceOps workspace from the workspace subtopic, and then integrations launchpad, which I kind of briefly touched on previously. And then we'll filter on pull-based log integrations and select the ServiceNow system logs integration. And this is literally like an easy button for HLA in that it doesn't even require mid server. It's a native on-platform capability to send your Glide system logs into HLA, which allow you to then navigate and search those with Log Viewer, as well as activates HLA in its search for anomalous system logs. So let's see. We'll put a description and click next. And then one of the improvements, in addition to turning this on automatically, is some intelligent filtering now comes out of the box, because there was, the platform logs can be noisy and some of the log traffic just is not really adding value from a debugging or a forensics perspective. And so the latest version, the latest platform patch level store app version will add some sensible filtering, which again, it can be modified, but it'll at least, not have you drinking from the absolute fire hydrant. So we'll just click activate for the sake of the exercise. Confirm. And so now the platform is going to just turn that on under the covers and monitor progress for you on this panel here. When you're actually running through the exercise, it may take a few minutes because these are running on such modestly powered compute hardware. It can take a little while for it to run through. And then what's going to happen is it'll start ingesting all of the logs that have been accumulating while your instance has been running. So the exercise is going to have you walk through Log Viewer and look through some example log entries from your Glide system logs. Really just revisiting some of the work that we've already done with Log Viewer, but just focused on that Glide system log capability. So you can see like it's got some catching up to do. It's ingesting on average over 3,000 logs per minute. So if I go to Log Viewer and now select one of the Glide system log components, and then if I open up the time frame, yeah, it's going to take a while for it to. And so the exercise just has you kind of go through picking. So it populates those components, but now it's still got to kind of build up the contents in Log Viewer. It's got to index it all in that Elastic Store container that's running. Yeah, so it it will probably take a few minutes before data is actually accessible in Log Viewer and before it starts generating alerts in Express List. But that's the sum and substance of that exercise. And like I said, this is what I just ran through. That now happens automatically by default when an instance with HLA is updated or provisioned in the first place. Okay, so especially given our little potential scheduling mishap, Dennis, are you ready to do your
Yep, I'm here. I'm ready.
Perfect. So again, just one last reiteration, these lab environments are yours to play with. You've got your video walkthroughs available in the lab guide. So and there's some appendices in the lab guide talking about the additional chaos scenarios you can trigger, as well as some example alert types that you can look for and try and produce. So please do make the most out of these resources that we're making available to you for the next 3 days. And thanks for all your time. And I'm going to stop sharing and turn it over to Dennis.
All right, perfect. All right. Do you see my slides? Okay. All right, folks. So thanks for those that stuck around, even though we had some issues with the way the scheduling was working. So to end it off on a summary note, so with HLA, as you guys seen from the lab and from the presentation, what HLA does, it cuts through the noise, go from millions of daily logs to a few meaningful alerts with no manual rules required. And what it does is detecting the unknown unknowns, which is basically what we're doing is surfacing novel issues before they escalate. We're also accelerating root cause analysis by providing real-time ML-powered anomaly detection that helps pinpoint problems faster. And finally, the ServiceNow platform log monitoring, providing native platform logs to catch platform issues early, instantly identify problems originating from the ServiceNow platform itself, as well as search and troubleshoot using Log Viewer to browse and search logs directly from within Service Operations Workspace. Hold on for a second, somebody's at the way.
Yes, the double-edged sword of working remotely. I don't know if we called it out explicitly.
Good.
I think there's a link. Oh, Dennis is back.
I guess.
Back to you, Dennis.
Yeah, sorry about that. Here's the link right here. We'll post it in the chat, but we do have a survey. We do have a survey for you to fill out. Here's the link. And the next piece is put AI. We also have ServiceNow is committed to your success. I want to highlight three offerings that are at the heart of our customer success ecosystem. The first one is ServiceNow Impact. It's a customer success product that helps you maximize value and long-term adoption, guidance, and support. Our training and certification resources available through ServiceNow University helps you build the organizational talent you need to succeed within your organization. And finally, Expert Services is our ServiceNow professional services team that helps you implement and optimize your ServiceNow investments. Finally, thank you all for your time.
Yeah, I really appreciate everybody's time. So I don't know if we explicitly called it out, but all these sessions the slides and the recordings are available on the Live and ServiceNow community page.